Alright everybody, welcome back to another Ask a Dev Unreal Engine live game dev stream of sorts. Today we're going to be taking a look at a little bit of more into control rig stuff. Specifically we're going to be taking a look at IK splines. Not as much in engine, we're going to do some stuff in engine, but because of how crazy things are around here right now, I'm currently coming to you with the power of solar. Because we haven't had power in a couple days. I'm where I live in California right now is under a fire evac warning and all kinds of stuff. So hopefully the sun stays out long enough for us to finish the stream. Things are definitely entertaining over here. And I didn't get as much time to prepare this time, so we're definitely going to be doing this a little bit more off the cuff. As always, a big shout out to the community before we get started. We had Aaron and Riley join our Patreon. Thank you very much for your support, y'all. Once again, you are the reason why we're here. And Warren, good to see you in the chat. Specta or PBM, off the rails, welcome. Thanks for hopping in as always each week. Warren is crushing it, helping people out in Discord. Dude, y'all, Discord is awesome. Seeing everybody helping everybody out. Especially this week, I had zero time checking from my phone with no power, etc. So it's very cool. We have a great community. Everybody's helping each other out, and no questions too small, too noob, nothing. Everybody's really cool. Some of them are pretty advanced, though. Not gonna lie. I look at them going, dude, I don't know that. I don't know that. So, anyways, so today we're actually gonna start a little bit in Maya. I don't know how much time we're gonna fill, so if we finish early, I'll just open up to general questions. And we'll go from there. So let's talk a little bit about spline IKs. And we're going to break this down in Maya. And the reason we're going to do that is because it is easier for me to show you the underpinnings of how all this stuff works in Maya. I believe, yes, you all can see my Maya. I do have the chat. So let me know how the audio is coming through and everything. For those of you that are here, I remembered to press the button today. Got a checklist. All right, so what are we looking at? This is we're going to call this our Rubik's tail, for example, for right now. It's important. I have it color coded on each side. You can see the sides are different colors. The reason for this is when we start talking about spline IK, really what we're talking about is we want a way to control a chain of joints that allows us to move either the top or the bottom and have everything in between get affected. This is particularly powerful for things like tails, spines, tentacles, ropes, chains, all kinds of stuff like that. And the reason being is when you want to pose out this stuff, the idea of having to pose each of these joints individually using FK, it becomes very cumbersome for the animator. And also there are certain things that just are super difficult. So let's for example, let's take this tail, and let's just say that we wanted to pose the tail. What? It didn't give me. Oh, let's just do it like this. So we wanted to pose the tail so that it was on the ground. Let's go a little bit more on these joints. We wanted to pose the tail so it was resting on the ground. Well, the problem is now, if I want this tail to remain on the ground and I do anything that moves my base joint, the tail's no longer on the ground. But with spline IK, I can do things like have it stay on the ground by offering different spaces and controls for our animators. So basically what we're talking about is we're talking about a way to control a bunch of joints. Now, super long-winded, but the way this works is what you do is we create a spline, which is just basically it's a line that goes through, or a curve that goes through our joints. And so let's just go ahead and create one in Maya, and I'll show you how this stuff usually works. So in here, I'm going to choose a spline IK handle. And what you do for these, generally speaking, the way these work is you give it a start and an end, and it creates a couple of things for us. You can't totally see them all, but one thing it created was this IK handle. That's just where all the logic stuff is at the end. And if I hide the joints for right now, actually, let's just do this with the curve and the tail. If I isolate these two, you'll notice that there's this curve that's been created. This curve is the spline that drives each of these joint locations. And the way that it works is this curve is made up, in this particular case, I believe this is a 3rd degree curve, and there's different, they're called CVs, but you can think of them as vertex points on this curve. And the trick is, as you move them, the curve is going to drive the shape of the tail. So this is generally how a spline IK works. What we're doing is we're manipulating the spline. So in this case, you can see we have 7 joints through our tail, but there's only 4 points on this curve. So rather than controlling 7 joints individually, we can control them with a simplified curve. And the cool thing about the curve is it allows us to create these great shapes like arcs and so on. And we can kind of adjust how this stuff works. Now you'll notice that the smoothness of this curve is going to have an impact on the smoothness of our shapes and things like that, but you can see what's happening. We're basically manipulating this curve, and as a result of manipulating the curve, we're getting different shapes out of our joints that are being driven by this. So let's bring back our joints just so you can see what's happening as I move these. You can see the joints are basically shifting to ride along this curve. Now, this is important to understand that it's a curve, and actually if we come over here, we can we don't actually, in this setup, I don't believe we have stretching. Okay, FK control, spline solver, twist mode. That's fine. We're going to get to stretching once we get to Unreal. We're going to get to Unreal in a second. But what I wanted to show you was, so we're manipulating this curve. The trick, the thing to understand about a curve, if I undo all this stuff, is it goes back to geometry. If we have this curve in our scene, you've got to remember when you look at the curve down the line, you're looking at a point. How do you know which way is up? How do you stabilize this? And what I mean by stabilize, all right, so here's the thing. If you want these cubes so that green is always up, you need to be able to tell the joints underneath based on the curve that green is all the way up. Which way is up in a curve? How do you know? And the answer is you kind of don't. And the reason you don't know is because if you look at a curve from the end, what you've got is you've got a point. And if you remember back to, like, I can't remember which school it was, geometry, but the number of tangents to a point is infinite. You could draw, this could be up, this could be up, any direction can be up. So the way this is usually done is there is another object that is created outside of your curve that is used to stabilize. Why do we need to do this? So let me show you what happens if we don't do this. So if we pick our IK handle and we turn on our twist controls, what I want to show you is if we now take our curve, and this is why I color coded this, if we take this curve and we bend it, do you see what just happened? All of these boxes flipped. So we have bright red on one side, and we have dark orange, burnt orange on the other, but you'll see that just moving that point flipped. The reason that flipped is because as the curve bends, which way's up now? Well, the problem is if we look at this IK spline solver, look at what's up right now. Scene is up. So what that means is in this particular case, up, if I were to, I wish I could create an arrow really fast in this. So let me just create a cube real quick. Or a cone, yeah, a cone will work, okay? Is none. Okay, so this this cone is pointing up. All right, the pointy end is pointing up. Okay, so this is where it thinks is up. So what happens is if this cone is at this position on the curve, the red or the bright green is up, if you will. And then if you get to this one, bright green is still up. If you get to this one, it's sort of still up, but now look what happens. When we get down to this side of the curve, which is up now, bright green's still up. Bright green is still up because it's pointing in the direction of the scene up. So there's an outside something, usually an object, another curve, or whatever it is that is used to stabilize the spline IK so that it knows which way is up. And if we select our spline IK, we can actually change that here just so you can see the difference. Right now it's scene up. If we change it to object up, start and end, Now we have to give it an object. So let's do this. Let's take this one. We're going to create 2 cones, and we're going to set them each to be our object up. So this is cone 1. So if we go back to our IK handle, the object up start and end, our world up object 1 is going to be our cone 1, okay? And our world up object 2 is going to be cone 2. So let's set that and watch what happens to our spline. So we'll set that to object 2. Okay, now we have our twist, start up, forward axis is up, axis is Y. Is that what we want? Yes, up axis is Y. Now, depending on where this cone is, this changes which way is up. And it's based on the twist. So right now, where this cone is determines what is up, and it's graded as fall off for the entire chain. So right now, this cone being up here, these first 2 boxes, you can see it's able to determine up by where this cone is. The further we go along, the easier it is for it to determine. Now, in order to fix this flipping problem, what I can do is I can move this cone to be over on this side. Now you can see all of my color coding is now aligned on the same side. So it's important to understand that creating the spline IK, what we're doing is we're actually taking our joints, generally speaking, loosely speaking, and we're gluing them to a B-spline curve, which is a curve that is mathematically created out of a couple different points. And as a result of that, depending on how many points we put in it, we can get all kinds of nice smooth shapes, and we get all kinds of cool things like stretch and fall off, and we can make S curves and all these kinds of things. But the game, the catch, is how do we stabilize this when a curve has no way to determine which way is up? Now, there are other things that happen in this where what we can do is you'll see fancy stuff. Like let's take a polygon cube. Let's create this. Let's just pretend this is a line. Okay, sometimes what you'll see is you'll see things that are done based on tangent. So what is the tangent to this curve? Well, the tangent to this curve, if you're looking at the joints, this is the tangent. Remember, this is what tangent means. Up here, our tangent would be more like this, for example. However, this tangent value can be done on this side of the spline, on this side of the spline, on which side of the spline is it done on? You don't know. So really, stabilizing a spline solution really comes down to a game of figuring out what the best option is. I'm going to show you a couple of things in Unreal in a second here so you understand what's going on. T1 Mach. German's one of my favorite languages, so I always seem, if I see that, I'm thinking T1 Mach. So anyways, T1 MCH, welcome to the stream. So anyways, what happens here is we're trying to stabilize this, and as a result of it, we're playing a game. Now, what will happen is oftentimes in a rig, when we create the controls, these cones would be parented almost like pole vectors. And by the way, if I move them to the side, you can see they have an effect on which way the twist is going. And then usually you can also affect the twist on top of it. If I click on this curve, there's usually, if I come down here to IK, yeah, here we go. So there's a twist, so I can twist on top. Because once it's stabilized, once it knows I can twist along the axis, usually there's even, some of them get really fancy and fall off. There's rolls, which just roll everything together, etc., etc. And you can offset them along the curve so that they're moving down the curve. This is great for things like vines and stuff that are growing. So these are the types of controls that are available to you. Spline IK is awesome. Splines themselves have an inherent problem with, which is how do you stabilize them? And so it's basically every solution I've ever seen in all the time I've ever worked on this stuff, it's literally about how do you stabilize it? And making those stabilization controls easily understandable for the animators so that they know that this cone is, when I curl my tail over, that this cone needs to be in a place that will give me a repeatable solution that's to prevent popping. Now, let's talk about one other thing that I think is at least worth calling out before we move into Unreal. One of the things that people do is to combat this problem of stabilization and not knowing which way is up is they'll get super fancy. And the way they get fancy is rather than using a spline, what they'll do is they'll use a spline combined with a surface. And the reason they do that is what they'll do is they'll create a spline that runs down the length of the surface. And the cool thing about this surface is because a surface is not just a single line down and has infinite things, what we can do is we can use two tangents to figure out which way is up. We can use the tangent horizontally and lengthwise, and then we always know which way is up. However, this also has a problem where if you were to twist this, you can get to a point where you get these flips in your surface. So that is another option here. But in general, most of the time, everybody, from what I've seen, these are usually called ribbon IKs, by the way. So we have spline IKs and ribbon IKs. And in this particular case, what we're talking about is spline. It's just something interesting. So let's take everything I just showed you and let's take a look at what is going on inside Unreal Engine with the spline that comes with the spline IK that was built for 5. This is currently 5.5, but we'll take a look at 5.1. So what we got here is we got our Rubik's tail. It's just a skeletal mesh right now. And what we're going to do is we're going to create a control rig for it. And we're going to try to set up a spline IK for this thing. So create a control rig. Now I'm not using the modular rig. Maybe we'll, if we have time, we can try the modular rig tail to see how it behaves. But we've already seen some funky stuff with that before in some of our prettier previous videos. So let's go control rig. And let's open this up and take a look. Okay, now this is pretty straightforward. And we're keeping this simple because part of when you're working in a system that you don't know everything that's going on is now that we have this knowledge of how a spline IK is supposed to work, we can see and evaluate what's going on and make better decisions based on implementations. So let's take and let's make this a little bigger for you all to read. Is everybody with me so far? How's everybody doing? It's Wednesday. Okay, pretty quiet. All right, so here's our forward solve. All we're gonna do in our forward solve, I gotta get out of my hotkey commands. Okay, all we're gonna do in our forward solve is we're going to drag out and we're gonna type spline to see what they've got for us. So there's a couple things that are worth pointing out. So we have a spline from items, a spline IK, a spline through 3 points, and a spline through 4 points. These spline through 3 and 4 points, this literally creates a spline. And we're going to see this when we go into the spline IK and we go down the rabbit hole, but let's just start with making a spline IK and seeing if we can get it to work. All right, now, one of the things that is important when we drop in a spline IK is if we mouse over this, there's a little text here that is easily missed. Notice that it says requires a minimum of 4 inputs, controls and joints. This spline IK solution cannot work unless you give it at least 4 points. So that is something that is very worth pointing out, probably because, and we'll take a look at it in a second, probably because if we go in here, they're probably creating a spline out of the 4 provided points. Okay, so let's go ahead and do that. So we're going to take joints 1, 3, 5, and 7. I'm going to right click. I'm going to choose new, add controls for selected. And I don't like these big round controls because they mess up our visuals. So let's just go with a sphere, sphere thick, for example, and let's make it white, just so it doesn't get confused with our Rubik's Cube colors. Okay, so we have our 4 controls, and then what we'll do is we'll right click this, and we're going to, oh no, they're selected. We're going to right click in our graph, and we're going to, oh no, sorry, my head. Take them, drag them into the graph, and create an item array. Okay, so we have an item array. These are our controls, so we'll pop those on here. Then our joints, let's take all of our joints, and let's drag those into our graph and create an item array. And then we're going to connect these into our bones. Now, it's super important to point out, so we've done that, and if we compile, this should already work. And if we grab our controls and we start moving them, it already is working, which is pretty cool. So, and then Warren's saying, I think there's a spline through 3 points too, but it's still minimum requirements. Double maps the points to the 4-point minimum. Yes, I think that's true. And that's part of why we're going over this, because some of you are just going to be able to take this spline IK or the tail that comes built in with modular control rig and just use that. But if you're ever a little more curious about why it is you might be fighting particular issues or whatever, having some of this more foundational understanding might be useful. Also, with everything that's going on around here, I didn't have as much time to prep this week, so we have to kind of go back to basics a little bit. All right, so on here you can see we have a couple options though that are worth pointing out. If we hold this down and we turn on stretch, you'll see that the spline IK is stretching to get to the end, which is kind of cool. Now I do want to mention that, so our spine's stretching out. You'll notice that my last control, we do have a little bit of an issue. If I pick all of these controls and I reset them, I believe it's Control G. If I rotate, watch what happens right now. There's some weird stuff that's happening down at the end. And it's because our last control does not have the same rotation values as the previous one. So if we take a look, we pick joint control 5, we look at our offsets, we have 0. If we look at joint control 7, look at our offsets, then we got a 90-degree offset. I'd like that to be the same as the rest of my controls, so I just reset those to 0. That way if I pick all my controls, even in a spline IK mode, when I rotate, they're rotating together. Okay? Now, so this is already working, and we got some pretty cool stuff with our stretch built in, which is great. Now let's take a look at how stable this is. So by stable, what I want to do is I want to take this and move this over and try to create a curve out of it. Okay, so we're just trying to create a nice arced curve like we had in Maya. There's definitely some weird things going on as I'm moving this. This doesn't seem like a completely abnormal shape. Seems reasonable. We probably have, but we definitely have some popping that's happening here. So what's going on? There's a couple things. First, let's try turning on stretch. That doesn't solve the problem either. But what I want to show you is this is a fairly basic C shape. Nothing too crazy. Let's compile this again. Now let's go the other way, actually. Now, the big thing to know was I created that C shape by translating, not by rotating. So if I translate this one up, let's try it the vertical way instead. This is basically sculpting the curve underneath with a little bit of rotation on the other side. However, when we rotate this, once again, we get some funky stuff going on in here. So the way that this curve is currently being run through these points doesn't quite behave the way I would expect it to. If I pick all of these and I rotate them backwards, and then we translate after we do the rotations, oops, wrong way, here, let me stretch it out. That is better. So in addition to, it is not just you. What this tells us is it tells us a couple things. It is not just using the translation of these controls to figure out where the underlying curve points go. It's got to also be using rotations. We will potentially see that when we dig into the spline IK here stuff in a minute. But another thing that I want to point out is look at something weird is going on here that I think is worth mentioning. If I move just this control, look at my base of my tail. It is not rotating. That is a little counterintuitive for me. What's happening here is this base joint is basically being counter-rotated as a result of the way this is currently set up. Contrasted with here, if we go back to 0 quickly, Almost there. Hopefully I have enough of it. Okay, cool. So if we go back to 0 here, if I bring this up and I bring this control point, watch what happens. This box is going to bend to try to maintain its alignment with the rest of the tail, right? This is sort of what I would expect to see from the base. But what's happening in here is this, even if I counter this up, it doesn't matter. This box, and this is why I specifically put on boxes with colors on each side so that I could visualize the stability of this. So I could visualize how much things are twisting, how much things are being offset. The fact that when I move this, that base tail, when I go down, it's kind of funky. If we reset this all, if we just go up behaves the way I would expect, but not down. That is a little counterintuitive to me. I don't know honestly, I don't know what's going on yet, because we'll have to take a look. But if we take this control and we go left to right behaves the way I would expect. That's cool. Okay, which is cool. So the things to look for as you're evaluating these solutions are, yes, the stability, posability, etc. But you also, in particular, where you're going to have issues is oftentimes at the base and at the tip. And the reason is there's times where if I take this control, imagine this wasn't a tail. Imagine your tail had a giant club on the end of it. It was like a chain mace, or it was the end of a character's spine or something like that. You've taken the tip, this end piece, taken this end piece, and you've posed it. It's right where you want it. So then you grab the control below it and you move it. If this control starts rotating and breaks the pose that you created, like over here, if I come over here and I go and I pick this one, watch what happens to the end. See how the last box is moving here? Usually you'll want to do something to stabilize that last piece. And there's different ways to achieve that. One is there's another joint that is parented in that's not part of the spline that follows its own control. Or there's another setup where the spline itself is made so that it doesn't affect this end joint at all. So these are the kinds of things that I'm looking for when I'm trying to evaluate this stuff. The fact that when I move this control left and right and up, everything behaves as I would expect. The base joint is moving, but not down. Something's funky. All right, so let's take a look at a couple other things before we dig into the rabbit hole. There's a debug mode. When you turn on the debug mode, this is super informative now that we understand what's happening. This giant red line, this is our stabilizer. Now we know what this thing is. So as I move this up and down, you can see this second red thing below that is actually stabilizing our spline. So if we do anything that causes this stabilizer to flip out, we are potentially going to get a flip in our setup. So in this case, if we were to pose it in a way that this red curve was somehow got behind the other curves. I don't know if I can get there. We could if we force it. So this is now flipped at this point. But even then, even though I've flipped it on its side, our boxes are kind of messed up, but they're still facing the right way at least. Even though I have no idea why this box is down here. Like that doesn't make a whole lot of sense to me. But there's still something cool that's going on as far as the stabilizing goes. And if we look at this, when we rotate, you'll notice you can kind of see this curve is being used as the fall off for our stabilization. So that's what this is showing us. And if you get into a pose whereby our curve goes all the way around, you'll start to get, so we've gone all the way around at this point. Yeah, it starts to get squirrely right here. You can see we have one of our joints. And the thing that's super odd, oh my goodness, Jamal Bradley is in the house. Dude, how are you doing? Man, you didn't have to do that. Thanks for the tip, y'all. Jamal is amazing. I miss you, man. It's good to see you. I love seeing your updates and stuff online. Thanks for hopping in and thanks for the tip, dude. Okay, so basically the thing that's super funky, Merry Christmas to you too, dude. Happy holidays. I think about you all the time. Jamal and I, just so you all know, Jamal and I worked together back in the day on Surf's Up and a bunch of movies at ImageWorks. He went on to crush it at Valve and is just doing all kinds of cool stuff all the time. So thanks for hopping in. It's good to hear from you. So anyways, what's funky about this to me is the fact that as this goes unstable, that this box is actually bending the other way. Keep in mind, this box is literally just, it's bound to the joint. So not only is the joint underneath rotating, they are counter rotating back the following joint. So the fact that this tail end piece, this last box in our Rubik's tail, is still sitting here at the end, but this one is bending sideways, and this is super funky to me. So there's a couple things that are a little bit interesting in the way this is working. One is when we get in these twist positions, and the other one is at the base. The fact that when we go down, the same thing is happening. When we rotate, when we move this down in space, if I can pick the control, when we move this down, the fact that this second section of our tail is separating from our first section means that under the hood, they are counter rotating this end tail that we are bound to, and then they're moving this down. So this tells us one of two things. We either need to build our own IK spline solver solution that works differently, or now that we understand how this works, what we could do is we could add another joint to the base, and that base joint doesn't get affected. It's not the joint that we're bound to, so our tail would be bound to, we would have a joint 0 effectively, and we would start at joint 0, and then joint 1 would be the first one that is actually getting the deformations. Seems a little hacky to me, but at least worth pointing out. This is what I'm looking at when we're evaluating it, but also to Epic's credit, spline solutions are not super straightforward or simple. I've never seen a perfect one. There's lots of ones that do really good jobs, but there's always something in there. So just something to keep an eye on. So now that we have a fundamental understanding about spline solvers, spline IKs, etc., let's see if we can't dig in a little bit to what is happening in the actual spline IK implementation that Epic was kind enough to give us. So if we just double click on it, this is the cool thing about all the modular components. Actually, you know what? Let me ask you guys. Do you want to dig into this spline IK that's provided by Epic, or do you want to see if we can set up a modular tail on this to see what it does? What do you all want to do? Jamal, you made my day. Not because of the tip either. It's just good to hear from you. SSH, I put everything on YouTube for free right now. It's just, the reason right now I'm just putting everything on YouTube for free. It's interesting. You and one other person, and in the entire time I've done everything online, the only two people who've ever asked for something that I charge for. Everybody else is, why isn't everything free? I do understand the Udemy request is a little bit, the way Udemy breaks down stuff, it might be easier to navigate and stuff. So I'm thinking about it, but it is a chunk of extra work. So, all right, we got at least one vote for breaking down the spline. So let's do it. All right. So, and you will find that this is actually pretty similar. So let's break down the spline first, and then we'll see if we can get to the tail. Now, because of the way this function is set up, I'm going to try to make this smaller so we have enough space to work with. And Epic was super kind, and they gave us all kinds of comments. We can see what's happening here. So let's break this down. So first things first, let's error check to see if we have at least 4. So if you ever tried to connect 3 or 2 controls, which usually with a spline, that's what I would first try. I'd try to put one at the base and one at the tip and see if I could control the whole thing. You won't even get a spline to show up. So this is why this, combined with the comments, told me that I needed at least 4. Then the very next thing, we got a sequence, so we know we're at least coming up here. Generate a spline from the controls. This is then used as the template. So basically we get the controls. This is exactly what we thought. All right, here's what's happening in here. We are basically generating a spline from the 4 points that are the transforms of the controls. All right, and then we're basically taking that and we're setting that to a variable as our template spline. And then after we do that, we come through here and we're building an offset transform array to generate the aim spline later. Okay, so this is where the offset transform is coming in. So basically, we've created our first spline. Then we're taking all of those points and we're offsetting them some distance and we're creating our second spline. And this is our secondary spline direction and we're setting it. This is basically building the transforms for it. And then we're going to go through and this is where we do the work. Step A, build the main spline and go through it. Now let's just double check something in our tail rig. Let's bring this back. I do want to, if we change our up axis to be -y, okay, that doesn't change it. Never mind. We're going to change our we're going to keep our up axis. It's the secondary spline direction. Rather than 5 and y, let's go -5 and y. Notice how it flips where our debug is. Now, we don't want this. I'm just showing you that if you're, depending on your axis facing, you will need to change this to match however your joint orients are set up. Okay, just something to keep in mind. So that's what's happening here. This is where this offset, that's what this offset is when it's building the transform array. Okay, now when we get down into C, C comes down in here and it executes another sequence. This takes all the joints. This is why comments are so great. And basically we get that this must happen before the closest point of value. Okay, cool. So what we're doing is we're getting whether or not we're stretched or not, and then we're fitting the chain onto the spline curve. If we go into here, let's see here. This is fits a given chain to a spline curve. And so we basically give it the bones, the spline, whether or not it's stretched. So this is a built-in function. We can't really break this down. But this is important to know because this gets us to another point. When we're working with splines, generally speaking, unless you are ultra fancy, you need your joint chain to be in a straight line. The reason you want it to be in a perfectly straight line is because when we fit to the curve, if the line doesn't fit, what it's going to do is it's going to move your joints to be on the spline. Because remember, it's mathematically trying to create a spline, and it's mathematically trying to match the joints to that spline. Well, if it's a straight line, the spline that gets created is straight. There's no movement. If you create a curve in your tail by default, it may not be able to match the spline perfectly to all of your joints. And so when you create your spline IK, you're going to get a slight movement in your tail, for example, that is not the default pose. We've talked about this in the past. I am personally a super huge fan of my default pose having 0 rotations on it, 0 anything. So in this world where we're fitting a chain on a spline curve with no way to potentially change that, we need to make sure our tails, our ears, our spines, this is why they need to be straight lines. Because if not, when you create it, you'll notice, in fact, last week when we were working on the tail, in fact, I might be able to bring it up. I think I still have it in this project. MCAT, quad leg. Here's our control rig. I don't have it in here, but what we can do is we can do this. No, this is not the right one. Maybe we don't have the... Oh, that's quad leg. MCAT, mesh. Here we go. Here's our control rig. This is what I'm talking about. This will take a second to draw. Okay, so remember we were working on this last week. If we watch the tail, if we delete the tail component, or is it this one? Nope, sorry, I lied. Actually, the control rig seems to do it right. That may be fun later. I was also checking out nanite on skeletal meshes. So if we very quickly take this tail and do the same thing with it, if we take our tail and we create an array of that, and we take our tail, every other one in here, and we right click and we choose new, add controls. We have our controls. We take these controls, we drag and drop them in here, and we create an item array, and we do a spline IK. I can show you what I'm talking about. Spline IK. Okay, so same thing we've been doing. These are our controls. Let's collapse this. Okay, now zoom in. Watch the tail. When we connect our controls and then we connect our bones, did you see the tail shift? It's super subtle. All right, I'm going to try to zoom in closer so you can see it. If I disconnect the solve, watch the tail move. See it shift? When I connect it, you can see it shifting. So the reason this is happening is because, actually Warren makes a really good point, I'll get to that in a second. So the reason this is happening is because this tail was not rigged and modeled straight. Now, some solutions can handle that, and they will build a curve based on the way the joints are laid out. We just saw that actually in the quad control rig that we built last week, but I wanted to point it out. It's important to know, at least with this spline solution, that if you just fit it to the curve, you're going to get movement in your chain if your tails and your ears and all the floppy things that you're doing aren't set up. So depending on whether or not, basically all that's happening in here is depending on whether or not we're stretching. If we're stretching, we're calling, both cases we're fitting spline on curve, but in one case we're doing alignment of stretched versus alignment of front. All right, now if we come back out of here, once we're done with this pin, we go D. So we basically fit our curve. Now we're building the aim spline. So this comes through and creates another spline from points, and it's getting the offset spline position. That's that red curve that we see underneath the spline. Okay, and so we set that as our local spline. This is for our debug. This is just drawing it if we want to visualize it. So this is where, if debug is enabled, we will draw it. If not, we're not going to draw it. And then what we do is we get the closest point on the spline to generate a position to aim at, and we're going to create an aim constraint. So what we have is we have our joint. It's pointing down the length of it's basically pointing at its child, because that's what joints do. And then, as we've mentioned, we have the spline that it's following, but we need to give it an aim. And so what are we doing here? We're getting all the aim transforms, and then we're going through for each one, and we're setting closest parameter position for the spline. Get the local spline, get the aim transform set at. We're setting the values. So basically we're setting the position. So we're basically, what we're doing is, for each of our aim transforms, we're getting a position on the spline, the closest one to where we are in space. So what it's doing is it's going down the spline, it's finding a point where our joints are, then it's looking at the aim spline and it's saying, where is that point? Let's store that value. So it stores that value, okay? And then when we're done with that, we come back out and we go down to D, and if we follow the D pen, now we're gonna attach the bones. So for each one, we're going to come through, we're going to attach it by setting the bone transform, and we're setting the bone transform to getting the bone transform, and then we're using the aim. And the aim up axis we have from our up axis, and here's our aim transform. This is that thing that we calculated by finding the closest point on the spine, on the stabilization spline. That's how we're determining which way is up. You'll notice that in this particular case, they're actually using the aim as our targets. That's interesting. And then we have the axis. This is a different way than the way I'm usually used to thinking about this, but it's cool. Okay, and then we have our debug. So, holy cow, we almost broke it all down. All right, and then finally, this is where we get into the end bone. So we're gonna attach the end bone to the last control. We're doing this last, and what we're doing is we're taking this, okay, this is cool. So this is what I was talking about earlier. Usually you have the base and the end, and you need to stabilize those, right? So in this particular case, what they're doing is for the very last end bone, they are parent constraining it to the last control that we created. So the reason that's cool is because if we come back to our Rubik's tail, this is why when we take this end bone, you'll notice as I translate it up, see how this last cube maintains its orientation relative to the control? That's because this last joint is being parent constrained to this control. That's why when I rotate this, the last joint is rotating the way I would expect it to. And this is particularly cool because generally speaking, this is what you want. We want the last, in a lot of cases. And what I mean by that is imagine the head at the end of a neck. When I move the neck and everything, I still want my head to maintain its rotation because I posed it. So I'm going to take it, I'm going to rotate it into place and all those kinds of things. So end of a mace, for example, end of a spine, end of a tail, taking it like any tail that has a bunch of spikes or a mace-like thing at the end of it, like this is a great example. You want that thing to be oriented the way you want it to. Now what's interesting is if we go back in here and we take a look at this, you'll notice there's a true-false case here. If we're using stretch, we're going to parent constrain it to the last bone. And if we're not using stretch, we're also, nope, maintain offset. What's the difference? Okay, check it. So if we're using stretch, we are going to parent constrain it to the last bone. Okay, if we're not using stretch, we're going to parent constrain it to the last control. So something to keep in mind. Now, one thing that is worth pointing out as we've dug into this spline IK is Warren's comment. All right, be careful to back up your function libraries, otherwise changes are permanent. So this is a really good call out. If you come in here and you accidentally make a change, you will literally break all spline IKs for all your stuff. So if you were going to come in here and monkey around, I would either make a copy, like make a complete other copy, or do it in a separate project where I think these function libraries, where is this stored? We need to make sure this isn't stored. Copy file path, show in Explorer. Where is this in our Explorer, y'all? This is in, oh dude, this is in the Epic Games folder. This is in the engine plugins folder. So if you mess with this, not only does it mess it up for this project, it messes it up for every project. So you don't want to mess with this on accident. So if you're going to come in here, play around, make sure, basically if I'm doing the kind of stuff we're doing today, especially if it's in the spline function, if it's one of the built-in functions, I do not save. But this was cool, and you can even see how it says it's been changed. Maybe I moved something, maybe I clicked something, but that would make me nervous. I would not change that. Sometimes I have a separate install of Unreal, but I would absolutely duplicate it. But that is a general breakdown of how the spline IK that comes as part of the function library works and why it works the way it does. If you want to build your own, you can. Now let's take a look at something else though. So if we go back, let's take a look at the tail. Let's take a look at the modular tail that we were using last week. And I broke it. I broke it because, okay, let's try this. Let's do this. Let's just see if we can build one quickly. Browse. Let's take our skeletal mesh, and we're going to right click on it, and we're going to create a modular rig this time. Okay, so with the modular rig, we have our base. Let's just take a tail, and here it is. Let's just drop it on root. And then let's take our tail. We're going to go joint one socket, start point, start bone. Oh, crash. Close without sending. Okay, here we go. Cool thing is now we can just open our quadruped from last week. Control Rig 5.5. Here we go. That's why we save often. All right, so while this comes back, does anybody have any questions as we're waiting for this to come back up? I'm going to skip the restore on this, by the way. Okay. And then let's bring back... We can probably just go into the MCAT now, since we undid the saving. This takes a while because there's so many elements in the modular control rig, it takes a second to open. Okay, so we have our tail. One of the things that we want to look at as far as our tail goes is, do we have any of the same problems that we had with our Rubik's tail? And it's almost an unfair test because this is, we kind of need, you know what, we need to do apples to apples, y'all. Let's go back to our Rubik's rig. Let's right click and create a modular control rig, a modular rig. Okay, let's open that up. Let's see if we can do this again without causing a crash. So let's take the tail, drop it here. Okay, so now we have our tail control. Okay, interestingly enough, it actually looked like it all just kind of filled in. We have some controls. Okay, that's cool. The controls themselves are a little difficult to pick. So let's take our controls. Let's see if we can translate them up a little bit. And that's Z, let's try 10. Compile. Okay, so that's not the right one. FK. Doesn't look like our transforms are moving. Interesting. Does our scale change? Not even our scales are affecting these? Okay, I'm affecting the wrong thing. I've got to be. IK control settings, local space, box thick. Let's go box thin. Wireframe. Currently we are in what mode? We're currently main controls is FK, default IK or FK. Oh, look at that. Hold on a second. That's way different. Okay, so alright, so we were just in the wrong default mode, I guess. So let's go back and change these. Let's go back to 1 on these controls and 1 on these controls. And let's get rid of this floor because it is driving me insane. And we'll go back to details. Okay, so these are all scaled to 1 and all scaled to 1. Let's go 0.5. Alright, that'll make it a little easier to select. Now I believe these are FK controls. So these are just our FK controls. So that's why those offsets are working the way I would expect. So let's go back to IK. Our IK controls, they are not paying attention to our offsets. As far as why that is, I'm not sure. Mirror axis, bone axis, second IK control settings, space, local space, shape, color, transform, rotator is just ignoring it basically. Area the IK uses the proxy rig based on selection, shape visibility based on selection. Okay, that's fine. We don't need to get into this. If we go to wireframe, what we can do is we can pick our control. In this case, oh, wild. That, oh, I see. So this is our base, okay? And then if we pick our next one, this is our box. Okay, there are, so we are still seeing some issues in this. Okay, and specifically what I'm looking at with this tail, what I'm seeing is as I move these controls, you'll notice that what's happening is as this goes down the chain, you'll see that I have a box that's flipping out at the end. Kind of weird. Not at all what I would expect. Let's see what happens when we pick some of these end joints. This could be just that we don't have our settings right. Let's double check a couple things with our settings in our tail. limits, where's our up axis stuff? IK, initial space, local, rotational limit, shape, proxy, filtered, default strength, default twist, up axis. Okay, we're gonna go with, let's try 1 and 0. And secondary spline direction. Unfortunately, I don't see the debug on this, but let's just see if that helps. Yeah. Let's try -5. I don't expect this to be any different actually than our Rubik's one. 1 and 10. And if we move this box, holy smokes, yeah, that's not the right direction. Here, let's do this. Maybe we can do it on the fly. Oh, I have 2 in. W. I was hoping to see how the modular control tail behaved relative to the other stuff. But so far we're not having any luck. It could just be my joint orients, as Warren is saying. Let's try 1, 0. And except our aimed direction should be X, but I don't know, I'm not sold, y'all. I am not sold. We would have to dig into this more to go even deeper on this. Because the other interesting thing is if we go down below 3 controls, it seems like we lose control. Also, the spacing of these controls is a little bit weird. What I wanted to see, specifically what I was looking for, by the way, is I wanted to see, yeah, okay, we can see it, and we know we have the wrong axis. All right, so the issue or the challenge still exists here, except what's happening is the axis is off. So here's what's going on. What I was curious about was, remember when we moved this control in a normal spline IK, the base joint was countering? All this is showing us is that same thing exists even in this tail, but in this case I have my axes wrong. Either my joint orients are messed up or I've just specified them incorrectly. And what's happening is the man, yeah, it's totally odd. So it's actually pretty wild the way this is set up, because the idea that I can get in a world where the child of a joint is being counter animated because of the way this setup is set up is it bends my mind a little bit, but it's worth pointing out from the overall standpoint. So I don't know that we'd have to dig more into the modular tail a little bit. The actual IK spline that we built in our Rubik's tail rig makes more sense to me in general, with the one caveat question of what's going on with the base. So yes, so this is something that is also we've mentioned before. We mentioned this during the quadruped setup, where I think I'm in 5.5. Okay, so what should happen is when we use a modular tail, what happens is in all their new components starting in 5.5, maybe not all of them, but at least some of them. I haven't looked at every single one yet, but every one we've used so far, what they do is they're trying to decouple the actual joints that are bound to the control rig itself. And they did this by creating this phantom rig. And in some, we talked about this before, in some cases the phantom rig is called rig, in other cases it's actually called phantom rig. I made a comment on this last time, but the point is we create a completely separate phantom chain. That chain should just work. And then all of our tail joints should just be constrained to that chain. But as you can see, something funky is going on there. And we are not going to solve that with 2 minutes left to go. But so I wanted to bring that up, call it out. As far as we are, the overall point and the overall thing to understand here, though, is when we're working with Spline IK in general, is there is a challenge, and the challenge is how do you stabilize it. And the way it gets stabilized by team tech art or team character setup or whatever is going to be largely dependent on team end requests. How do you want it to work? And you will find all throughout my career, I've found that there are different ways to stabilize the top and the bottom and different solutions. And it's one of these things that it's just worth mentioning so you understand what's going on to it. If you start seeing stuff like this, because the thing that's cool about modular control rig and control rig in general for artists, for us artists, is it gives us the ability to potentially build our own rigs on the fly without necessarily having to have a completely 100% seasoned tech art character setup artist on staff or helping us for our own independent projects. So that's why I'm trying to break down some of this stuff so you all have an understanding of what all is going on here. And you can make wise decisions about when it's worthwhile for you to build your own. In this case, if I needed a tail because I was doing a freelance job or I had a little rig that I wanted to set up with and I didn't want to learn the art of rigging on the fly, I would possibly consider just adding an extra joint at the base using a normal Spline IK, and then I would have the controls that I need to get done what I want to get done. And then you can basically add spaces to it. You can do cool things in animation like have the tail drag on the ground because it's following world space instead of tail space or parent space and those kinds of things. So a little bit different today as a result of fires and no power for 3 days and running off solar. I didn't have quite the prep time. Hopefully you all found this helpful. Let me know what you all think. Did anybody have any questions before we wrap up today? I think I still have enough solar left. Arthritic, no worries. Glad to help out. Roger, good to see you again. I didn't see you hop in. Thanks for joining the stream. For a quadruped procedural walk, is there better to use control rig or just using some plugin? I mean, is there a plugin that does that procedurally? Quadruped walks are fun. If you want to see some really cool procedural stuff that's done with control rig, I would check out Lincoln Marginson stuff on Udemy. It's really, really well done, broken down really smoothly. I do have the Octobot series that is a breakdown of a 8-legged character procedural walk that you can go through. But generally speaking, I saw one, it was almost like a SIGGRAPH type thing, which was it was a procedural walk, and I think these are going to get better and better over time. But wow, dude, Roger, you didn't have to do that. Thank you so much, y'all. I very much appreciate the tips too. That's very cool of y'all. I very much appreciate it. And it does, like I said before, you know, I decided not to teach at a school because they would, once again, they would lock it all behind a paywall. Nobody would have access to it. And I thought that maybe there was a way that we could do this in a crowdfunded type simulation on YouTube. And, you know, so every single one of these tips, everybody who's in Patreon, they help keep the channel going. Helps helps justify the thing, even though a huge part of this is really just about giving back and leaving something for my daughter to be able to watch at some point. So can you show us the sample robot cannon thing they provided with Control Rig's simple sample project? Yeah, we could do that maybe next time. We did a lot. Okay, now you all are just doing crazy stuff. Yeah, SSH, we could do that. We could kind of, if you want, what we can do is one time in one of these future ones, we have some time at the end, we could do a breakdown of how that thing is set up, maybe a walkthrough of the cannon thing. That might be cool to see what they're doing. Yeah, we did, dude, we built a lot of really, so Jamal and I, we built a lot of really cool tools out of necessity for animation on some of the projects we worked on. And we had a lot of fun. Fun story. We'll wrap this up with one fun story since Jamal's here, and Jamal will remember this. On Surf's Up, for anybody who hasn't seen Surf's Up, it was a movie. We were character animators on that film, and IK spines were a fairly new thing. They weren't really well established in the industry, but everybody had them, of course. Okay, but for some reason on that project, somebody decided to ask the director whether or not we could use IK spines or not. I don't know why. Like, generally speaking, the director, that is not something you would typically ask a director. The director should just not care what's actually making it happen. They just want, do they have the poses, the performance they want? Great, who cares how we get there? But somebody asked the director, and as a result of that, the director's like, no IK spines, because we want everything to be fluid and etc. So we were not allowed. They took all the IK spines out of all of our rigs. And we're talking about penguins, right? We needed the IK spines. So what happened was the crew built a black market IK spine that what we would do is for the shots that we needed it, we would basically use this tool to put an IK spine on the rig. And then we would animate it all, get it the way we wanted it, and then we'd bake it all out and remove the spine. So it was all FK when we sent it in for review. And so we had this whole underground IK spine thing that was going on that project. So we built a lot of fun tools. We had a lot of good time together. So with that fun little blast from the past, it was great. But anyways, thank you all for hopping in. I appreciate you all supporting the channel, being in the live chats. It helps make sure I have the audio turned on sometimes, which is good. We have one more chat next week. We have one more live stream, and then I think I'm going to do something crazy. First time in over a year. I may take a week or two off for the holidays. Now, as a result of that, I may do a pre-record. We may do a premiere or something. I don't know. We'll see how much time we have and when we get power back. But I hope everybody has an amazing rest of your day, a great rest of your week, and I will catch you all on the next one. Take it easy.